Our gyroscope rotor consists of a piece of 3-inch cold rolled steel. This is what we've got to start with. This is our stock material. This is saw cut. So the first thing we're going to want to do is clean off both sides of this thing and take an actual thickness measurement. Right now it's reading a little over a ½ inch thick, so we've got plenty that we can take off. We're going to end up at 0.375, 3/8 of an inch. So yeah, we'll head over to the lathe. We're going to use soft jaws to cut this thing, so we'll show that on the lathe over there. Similar to on the milling machine, that allows us to clean up for any errors and eccentricity of the lathe jaws itself. And in this case, it's going to allow us to grab this relatively thin, large piece of material that wouldn't otherwise fit all the way up inside our chuck. So moving over to our lathe with the soft jaws, there's our cold rolled steel. A little closer. We're going to load this. We're going to move our tool out of the way a little bit here. So we're going to fit that in there. Reasonably snug. We want to be working on our low range because we're in steel and we're at 3 inches. I think we have something in the neighborhood of about 100 RPM or something when we're out at the 3-inch diameter there. A little bit different this time. We're going to use a carbide bit. The cutting material of this carbide is much harder than a high-speed steel, and this will allow us to take a little heavier cuts on our steel piece here. The angles of the cuts and so forth are all basically the same. You can get carbide in different shapes, but this represents our standard right-hand cutting thread. Nice slow speed there. I've already gone ahead and adjusted the tool height. And this is one time when we're really going to want to use a little bit of oil. So let's go ahead and use some oil on that. And I'm just going to brush a little bit on and a little bit on the bit there. And then we'll take a nice light surface cut and see how this is looking. So I'm just going to bring the bit in, no measuring at this point, so just till we touch off. In my hand, I'm going to slowly work this out. Very light cut. We're nowhere near flat, so we want to take this nice and easy. On this camera here, I don't know if you can see, but I'm trying to use 2 hands and keep the rate of cross travel feed here as consistent as possible. It gives us a little smoother finish. Let's take a look at our cut there. So I wouldn't normally take this out of the lathe, but I want to demonstrate to you guys what that looked like. So as I mentioned, our saw cut surface is really very rough, and so all we did was take off this part here. The part was not quite flat in the jaws there. So we're going to do this as kind of an iterative process, working back and forth on both sides here. The reason for that is we don't have a good way of grabbing our part on the outsides here and then making our faces completely perpendicular to our sides. On our soft jaw, we've got just about a 1/16 of an inch or so that's grabbing hold of it. So a lot of what's centering this part for us is how flush this is to the backside of the jaws. And since we don't have any flush surface set up yet, we're going to kind of approach that gently to make sure that we don't cut ourselves a really kind of an odd angle into there before we then try to flip this in there. And so we're going down to 3/8 of an inch, and we're over ½ an inch to start with, so we have plenty of material that we can remove and get ourselves down to there. So when we get a little bit closer, we're going to, in fact, I don't know if you can see that on this camera here. When I try to lay that in there, there's a lot of wobble in there. And wobble on that side as well. So we're going to load that in there. We're going to take another quick cut on the back side. We'll flip it over again. And like I said, this is kind of a slow, a little bit tedious process, but it's important when you're starting off with a large piece of rather thin material. So I'm kind of checking for flatness as I move this across here. Okay, and I'm going to move in just a few thousandths and come back across with this now. And there's no way to speed this up other than with the magic of Hollywood and editing our video. Now granted, I am using carbide and I can use a little higher cutting speed, and I will do that as soon as we get this part a little more squared up. I want to make sure we've got a good grip on it before we spin anything any faster. Okay, I'll move in just another couple of thousandths here. Again, these are roughing cuts, so we don't need to be real concerned about the finish that we end up with. Run this dial a little faster than we would for a finish cut. There we go. So now you hear that there's kind of a continuous sound. It's not going, grind, 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 grind. So now we're sure that we're actually cutting all the way across the face here. And I could put the auto feed on and do this. The only problem with using an auto feed at this point is that the chips tend to get very long. If we're taking a fairly heavy cut, the chips are very strong, and they tend to be continuous if we use the auto feed. Whereas if we do it by hand, we tend to break the chips off a little bit more. All right. So pretty rough finish, but we've cut all the way across that. Let's flip our part one more time here. Draw it forward. Alright, hopefully that's a reasonably perpendicular surface to our sides now. Slide that back in there. So all I'm doing is basically coming up, touching off the very edge there. Doing a real quick, you can see the spiral on there. So you can probably see on the camera there, we're generating a bit of smoke. Chips are hot enough to burn the oil. We're not quite discoloring the chips yet. See a little bit of brown in there, so we're probably taking a reasonably heavy cut. Reasonably cleaned off there, so let's go ahead and measure our thickness now. So you may notice that this key where we put the chuck key in, the keyhole here, is marked in red. We'll mark our piece off here. In fact, we can go ahead and do that now. I'm just going to use a high-speed tool bit, and we're going to just mark off on either side. This allows us to index our part. If there is any eccentricity that's been cut into this in our soft jaws, if we return our part to the same location each time, we'll maintain that same eccentricity all the time. So let's go ahead and loosen this up here. Take a thickness measurement. We're not looking for much precision yet, so we'll go ahead and use our calipers. We're still reading 0.51, 16, 17, about 0.517. So we have plenty to take off. So I'm going to look for our marks that we put on there. Line up like this. tool bit looks a little bit high. I'm going to go ahead and move it down. That looks a little better. It's running about 150 RPM. A bit of oil on there. And this time I'm going to go ahead and use my my cross feed, so we're moving out. So I'm just going to touch off on that. Yeah, we'll be here at all day at this rate, so I'm going to do this by hand. Like, we're going to go real heavy and see if we can turn our chips colors. You know, so I'm doing this turbo, but I'm still trying to use two hands and keep a pretty consistent speed. I'll slow down a little more as we get closer to the outside of reasonably good there. So with each cut we want to add a little bit of oil. Just a light coating there. Let's turn on our digital readout. I think for anybody watching, this is going to be the most boring part to make because it takes so long to cut this down to 3/8 of an inch. Good. So this will be about 15 thousandths thickness. Generate a lot more heat with this than we do with cutting on aluminum. Okay. I think we can actually arrange our cutting bit here to be a little bit more efficient. Cutting from outside in, if we spin this angle around just a little bit here. Sure we don't hit our jaws. Yeah, that looks pretty good. All right, so I'm gonna zero out my longitude. All right, so let's try 20 thousandths this time. Add a little oil. Fairly heavy cut there. So we're really smoking off that oil. If I'm really consistent on my turning, then I get these long chips, and if I stop, then I can break the chips off. Alright. If you look at that, our tool bit's just a tiny bit low. You see we've left a little bit of a nub there. Let's go ahead and raise this just a smidge. All right, we're going to take another pass at about 20 thousandths here. Zero myself out again here. Alright, so if I just touch, back up. Go to about 20. And cut away. It's a little better. Now, if we want a nicer cut, we can actually turn this in a little bit. And we'll do a finish cut on the back side here. Some oil on there. So I've increased the speed of the spindle here about 200, maybe 250 RPM. While we're cutting in the smaller diameter, we can get away with this. In fact, a lot of CNC lathes will actually vary the spindle speed throughout the cut. And this allows you to maintain the optimal cutting speed. So it's about surface speed. So the surface speed when you're in at a small diameter is lower than it is as we get out. So as the tool bit moves its way out, I can manually adjust the speed down a little bit here so we don't exceed the surface speed cutting for this material in this cutting bit. Now, carbide usually has, I think, roughly 3 times the cutting speed limit that high-speed steel does because it's so much harder. And this might be a case when we want to rearrange our gearbox over here to make this thing cut a little quicker. I don't think I have enough memory card or battery in these cameras in order to film the entire process, at least not in one shot today. I'm going to go ahead and finish this face off. We'll do the real slow turn, get a really nice finish on this face. Then we'll flip it over. Then we'll take our remaining cuts down to thickness, and then we'll kind of hollow out. Well, I'm about halfway there. So once we've finished cleaning off this face, we'll bring in another tool and we'll reach over the back side of our disc there and try to clean off some of the longitudinal surface. That'll give us an opportunity to make sure that the face that we just cut now will be completely square and perpendicular to the longitudinal face essentially of the bar. And if we do that now, we clean that up, and when we flip the part around, our jaws will be pressed up against the machined face that we just cut, and also our jaws will be gripping on the machined longitudinal face that we also just cut, and everything should stay nice and square and concentric with each other. And then on that other side, then we'll cut down all of our parts, come back in and add our hole and ream it and so forth. But we're going to take our time with this one, get a nice clean surface finish on this side. I'm only taking off about 2/1000ths of an inch, so this is just a real light cut. I'm going to slow that down a little bit as we approach the outside edge here. We're running about 200 RPM. Again, I could probably run about 300 RPM all the way through with a carbide bit. But the easier you take it, usually the longer your tool lasts, and I'd like my tools to last as long as possible here. So. All right, so that's done. Let's go move our carriage out of the way. I'm just going to clean up our surfaces here real quick. Okay. Yeah, nice smooth finish on there. You can see that in the light there. A tiny little nub on there. Sometimes you get little burrs or a buildup on your face of your bit there. That looks pretty good. So what we're going to do now is grab this other bit and we'll reach kind of over the back. Alright, does this guy give us any reach into there? So first thing we'll do is make sure that we clear. Okay, and jog. Just clears. All right. So to cut off this little bit of longitudinal face here, we're going to cut on the back side. I've got a left-handed side. Actually, take it back. I do still have a right-handed cut bit. But we're on the back side of that, so we're going to rotate our lathe in this case the clockwise direction, counter to how we normally do. And I'm going to confirm that I can back this guy up here real nice and close. And I'm going to go ahead and, just for a reference point, touch off my cross slide here in my longitudinal. So I've 0-0'd on this corner out here. And we're going to add a little bit of oil on there, oil on our bit. Alright, I'll come up just to the part. I'm going to back out just till I touch off. Okay, so I'm going to want to use my longitudinal feed here. So pop this guy out, testing. Okay, so I'm moving in the correct direction here. In fact, I'm actually going to do this with the machine stopped. See how close I can get without hitting anything. Now I'm going to zero my longitudinal. Now I know when I hit 0, I've gone as far as I want to go. So this is a little safer way of doing it so I don't hit my jaws, my chuck here. They are soft jaws, but if I hit them, then I have to go back and recut them and start all over again. So that's kind of a pain. So this is just a real light skim coat. I'm going to watch my indicator up there since I can't see over the back side of my part. Right down to about 0. It's good. Back out about 3/1000ths or so, 4/1000ths. Right till I just see a continuous cut all the way around there. And I'll go ahead and feed this guy out now. So I've switched back to a high-speed steel cutting bit. So I do need to take this a little more gently. And keep that RPM down. I can hear this inconsistent sound, so I know I'm not getting a continuous face cut, so we'll need to come back and do this one more time. But this is the difference between the eccentricity of the stock cut material, which may or may not be perfectly round, and the face that we've already cut on there. So if we had one continuous cut around the outside as soon as we started off, there wouldn't be any point in doing this. So. My hand here, you can still see this part didn't get cut at all, but never even touched it. So we need to go a little further. There we've got a nice clean cut on that side. But you can see, I mean, that's not even 1/1000th of an inch. I can't even really feel that with my fingernail. So, all right. I go the right direction. There we go. So I'm going to run this back up to our 0 on our longitudinal feed. Alright, here we're going to add a little bit of oil. Dial it out about another, it's about 5/1000ths or so. And engage the longitudinal feed. You know, this isn't called out necessarily in the design of our rotor to do this extra step of machining on the longitudinal surface here. But from my experience, if you want everything to line up and be balanced, as in the case of a gyroscope, you're going to want to do this cut. So I'm going to jog this around nice and slow, taking a look. So we've got a consistent cut all the way around. That's great. Okay. So I have a very slight edge on there, so I'm going to knock that off with a file. This is a little tricky to do when you're this close to your jaws. So I'm just going to reach in there, and all we're trying to do is just touch. We just don't want to cut ourselves on that edge. That's it. There we go. All right, so this face and this side are now square to each other. So we're going to go ahead and grab our chuck key, release our part. So I'll bring this over to the camera here. So hopefully you can see this is a nice smooth surface on there. We've got a cleaned off surface on there, all the way around there, so consistent. So now we're going to take that, and here's where it starts to really matter how we line this back up. But I had marked off so a little tab. So I'm going to line that back up with our red Dicom on there. Also going to make sure that the face of our jaws is perfectly clean. Make sure that's on there, sit perfectly flat. Now that we've machined both sides of our rotor and machined it down to a thickness of 0.375, 375 thousandths or 3/8 of an inch, we've got to come back in and cut out these reliefs in here, if you will. Remembering that we've got a 45-degree angle coming off the center and then a straight angle coming back out. So I've gone ahead and actually reground a new tool bit, high-speed steel. This end here was just a squared off blank end. That took me close to an hour, 45 minutes maybe, to grind that into the nice shape and so forth. So our goal with this is going to be to, looking at it this way, be able to move in, cut, over, and out. What we'll have to do is do a clearance cut first and then come back in and cut the 45 and then blend at the bottom. So this tool will allow us to get this 90-degree shoulder in here and carve out most of that material. Then we'll have to come back in probably with a regular right-hand tool and make that nice 45 and then blend those in there together. So let's move this over. We'll load that up in our holder here. And since this is a newly ground bit, we'll have to double check the height of our bit relative to the center of our part. And let's see, that looks pretty darn good. I think we'll give that a try. Okay, so according to our plans here, we've got a shoulder that is a 3-inch diameter, so we've got 3/8 of an inch shoulder on there. 3/4 of an inch at the total. So what we're going to do is we're going to locate our bit off the edge of our part and we'll move across. This is going to be a left-hand turning operation. We're going to actually cut our part on the back side, so we'll be rotating in the clockwise direction in this case. But we can measure off from either side of our disc since it's round. So the first thing I'm going to do is bring this over, and this is my sharper edge. Say sharper. This is the edge that is coming in and touching first on our part, and this will allow us to make sure that we're not measuring, from the side of the bit or something. So I'm just going to touch off on that, zero off, And since we're going to work over to the opposite side of our part, we moved here, and I said this thing measures in radiuses, so there's about 3 inches or so. We're going to move all the way across. Here we would be 6 inches. We'll kind of confirm that. Yeah, it looks pretty darn close to 6. And then we're going to come back at 3/4 of an inch. So we're going to go to 5.25. We're actually going to come back a little under that. Let's go to 5.240, and then our last cut, we'll take it out to 5 1/4 and clean it up. So what I've done now is that I zeroed off on the front side here. I measured all the way across. My machine tells me that that's 6 inches because like I said, it measures radiuses instead of diameters. So I brought it over here to 6 and then back to 5.25. So the 3 inches of the machine thinks is 3 inches of radius plus that. So what I'm going to do is turn the machine on and lightly cut a little line to score that. Then we'll come over and do the same thing. We've got basically 3 inches plus the 3/4 on there, so we'll mark that one off. And then we can basically continuously remove material in there, being sure to not take out that 45-degree shoulder in there. So let's give that a shot. So we're in the low range, our speed is all the way down. We're going to jog, make sure everything's clear. Yeah, we look fine. So starting the lathe in reverse direction, cutting on the back side. I'm at 5.24. Then I'm just going to tap this guy in, take a nice light cut. And here we're going to want to add a little bit of oil. So let's zero off our longitudinal feed. We need a total depth of 1/4 of an inch. So we'll go to like 10 thousandths to begin with. Stop on our gauge reads about 4 inches. So we don't want to cut too far. Our tool bit is doing not too bad. Actually, I have a little bit of material buildup on there. So we'll scrape that off. So right now I'm just going to go ahead and check out this 3.75, and we'll leave ourselves a line on there so we don't miss that in the future. And again, so it's 3.75. I'm going to go to 3.6, maybe 3.6 and a half. Sorry, 7.6 and a half. And then we'll mark ourselves a little line on there. Okay. So let's see if you can see that on this camera there. Try to push it down here a little closer there. Okay, so that indicates as far as we want to cut in this direction, and then we need to maintain a 45-degree angle from that line into the part, and then this will be a 90-degree shoulder over there. So continue down to 1/4 of an inch. Put a little more oil on there. And this would be a great opportunity for a time-lapse video. More the right direction. So up to 5.24, somewhere thereabouts. Make sure everything's tight. All right, let's see if I can take 30 thousandths off in one cut here. Well, that's a fairly heavy cut. Look at those continuous chips. Okay, we'll stop about there. Come back out. You can see I am adding oil while the part is rotating. We're only going about 100 RPM, and with the long brush here, I can keep my fingers and stuff well clear of any moving parts when I do that. It is possible, though, if you're not careful, to suck your brush in and destroy it, possibly your part, other things. So you still need to be careful. Keep the brush away from the cutting bit as you're adding the oil if you can. All right. So I'm purposely stopping every little bit to break off those chips. I feel like my tool may have moved just a little bit, so I'm going to make sure this is good and snug here. We're applying a lot of forces as we're cutting these low speed. Carefully pick these up. Wow, they're kind of hot. These are the chips that we're making off of there. See, quite springy. I'd be kind of curious to get calipers or something out and try to measure those. Maybe you can see the chips a little better on this camera here. So the edges of these things are usually razor sharp. All right, brush a little more oil on there and continue our way in. So I'm just going gently with a longitudinal feed till we get to a depth. I'm taking roughly 20 thousandths or so at a pass. A little coating of oil. Let's see if we can get down here our first 100 thousandths here. All right, to give ourselves a little more clearance here, I'm going to move out and I'm going to move that back edge. Clear this all off here. See the back edge of my bit there. Line it up with that hole that we made. I'm sorry, that groove that we made right at 3/4. About there. And then I've got my compound rest set at 45 degrees, so I can use this now and move in at 45 degrees very gently. Oh, that is a lot of force on this guy. There's just really no pretty way to do this. This is essentially a boring operation, which normally would start out making a hole with a drill bit or something, and then working your way from that and clearing out the hole. But in this case, yeah, in this case our setup isn't rigid enough. Okay, we're going to stop there for a second, and in order to make clearance for the back side of our bit around the center here, we're going to go ahead and switch bits, come in and work on that 45 degree a little bit, clear out on that side, and then we'll switch back to this one again. All right, so I'm gonna swing that up so you guys can see on this camera here. So I've gone ahead and switched out with our good old carbide bit here. I personally really prefer working in carbide because it's so much harder, it makes life so much easier. Harder toolets make life easier. So we'll tighten this guy off. Lock our tool post. We'll double check our center height. Okay. So I'm going to touch off, and this will allow me to repeat this because I don't have a digital readout for my compound rest set at 45 degrees. What I need to do is set my longitudinal feed at 0 and dial my cross feed until I get right to the edge of where I'm going to begin my 45 degree, my bevel. And I'm going to set the cross feed at 0 as well. And now I can come back to 0, 0 on these guys and then move our cross feed in and out as needed. So again, we're still working on the back side. Lathe is in essentially in reverse. Brushed a little bit of oil on there. And now I'm going to go ahead and dial in with this 45 here. And I can get a fairly heavy cut in there, and then we're going to cut over. Make sure you're getting this on this camera here. Yeah, that's pretty good. Okay, and then I'm going to bring my cross feed back to 0. Right about there. And then dial in our compound feed here a little ways. And cross feed across here. Let's add a little bit more oil in there. Okay, as I get closer on this one, I've got to make sure that this nice big carbide bit doesn't hit my part on the back side of the bit. Drop oil. All right, I think we can switch back to our other bit now. Spin that back around here. Smack the camera. All right, so we're looking for a 1/4 of an inch depth. So I'm going to come back and re-zero everything. We moved our tool bits around and everything. So the longitudinal feed is zeroed off from that. And I'm going to come back all the way over here. Hopefully we don't run out of room. Touch off on the side of our part there, zero our cross feed. confirm. 5.24. Perfect. All right. All right, so we'll be cutting in the reverse direction here. Bring our bit up just a touch off. So, all right, our depth is 1120, about half, not quite halfway there. Let's see if we can take this up. All right, we'll clean this out down here. So I haven't been able to really keep track of how far I've been heading in there, so we're going to go ahead and pull our part out. I'm going to rotate this around to our indexed chuck key slot here. All right, let me grab my micrometer. Okay, we have chips all over our part here, so let's just wipe that off with a paper towel here real quick. So, when measuring something like this that has a little bit of a recess, we've got to make sure we pay attention to which way this is oriented. If I put this on here this way, you realize that I'm not going to actually measure the true depth of the material because our shoulder is going to rest on this little shoulder where the anvil is there. So, I want to make sure we're this way. And I believe we're looking for 1/8 of an inch. Yeah, 3/8 minus a quarter. We're going to go to 125, so we've got 208 on there, so roughly 75, about 80 thousandths or so to go. So I'm looking for the little mark that I made on there, right there on the top, and that guy is going to line back up. Make sure our jaws are nice and clean. So line back up on there. Tighten that down. And similar to when we're setting a part down in the jaws of the milling machine, we want to do something similar. We want to just tap our part in, make sure it's sitting all the way flush back against our jaws there. Okay, and we'll just confirm we're good and snug. All right. So, as I said, about 83 thousandths or so to go from the end. I'm going to go ahead and carve that out with this bit, and we'll come back in with our other one and basically machine that until we have a nice even match on there. So let's go ahead. A little oil. And you may have noticed we have a really lousy surface finish on there right now. I'm taking really heavy cuts. All right, 125. We're going to zero out our longitudinal feed. And so I'm going to aim for about 80 thousandths, but we'll take that and probably 4. We can get a little bit better finish on that. So I'll do one more last pass. Take this down until we touch off in the back there. Bring it out a little bit. Dash of oil. You can see on this camera here, I'm trying to do this consistently as possible. All right. Not too bad of a finish on there. And Okay, and we don't have enough clearance to get our micrometer in there, so we're going to go in with our other tool bit, clear that out, and then we'll be able to measure the bottom and we can clean it up if we're still a little thick there. It should be within a few thousandths though, I think. So. Smack the camera again. We still look okay there. So here's a good opportunity to jog our, there. If I've gone ahead and started up our lathe at this location, perhaps you can see here, our compound rest would hit our jaws. So put that in neutral, you can see here, we'd have problems. So why we wouldn't want to go ahead and just start that up without double checking what we're doing. And also bringing our bit all the way into where our final pass will be. You know, we got to remember that, you know, we will be moving in, so if we start off at the face, we might clear just fine, but we need to check all the way through the entire path that we plan on cutting. So that's not going to work. What I need to do is move my tool rest out, my tool post out a little ways on the rest there. So again, we're going to double check, make sure we can clear everything. So at the beginning of our cut, we look good. And we've got plenty of room to finish our cut. So, all right, so we're back into high-speed steel and we're cutting in the outer diameter. So I'm going to go ahead and slow this back down close to 100 or so, about 110. All right. Actually, before doing that, I'm going to double check with my depth here. So we'll zero our carriage. See how we're looking there. Yeah, and I can feel with my nail how much more of a ridge I've got. I don't know, 10 thousandths or so to go. Hopefully we didn't go too deep on our chamfer cut. Okay. Move out. All right, I think that's our finish pass. Yeah, it's a reasonably good finish in there. And we have our depth on that guy. So we're going to come back one last time with our other tool bit. finish up that 45 and make sure that our depth blends in nicely. Tool post is locked. We're going to swing this guy around here. Alright, so I'm going to slide in a nice pointy carbide bit that's normally used for threading. But I think it's the only thing that's going to give us the reach that we need to get in there. Alright, let's check our height on this guy. We are very high. Okay, so what we want to make sure is that we've got clearance on the back side. We do, but just enough to make the cut, because we want to get as much reach in this way as we can. So kind of balance the two here. So continue to bring this back until the angle just clears. Call it just clear. Alright, let's make sure that we can do this without hitting our part. That's about as far as we can go on that one. Alright, we'll just have to do this in 2 passes because I can't reach both sides at the same time, even with this bit. That's about as far as we can go without hitting anything. Okay. Rotate our tool bit around a little bit. Find where we can reach into that corner. Too much of an angle on there. So all of your theories can be good about the best angles to cut things at, but if it doesn't fit, it's not going to work. All right. And just clear everything. Yeah, all right. So I want to bring this up. I'm going to use my compound rest. Again, I'm not measuring anything. I want to just touch off on that. A dash of oil, maybe. All right, that's it. And believe it or not, I think we're going to have to come back one last pass with this tool bit in order to clean out that corner. There's just a little bit of a ridge in there. Everything else is done. Everything's flush. There's just one little ridge in there that I just couldn't quite reach. So we're almost done with this part. probably want to be done with this as much as you guys do. All right, everything gonna clear. We need just a little bit more angle on our tool bit there. Fit that in there. That looks like we can just barely go the right direction. All right, I'm gonna put a dash of oil right in there. To the corner there. All right, this is looking nice. Right in that corner. Let's try one last, let's see, 1/1000th of an inch finishing pass on the inside of that rotor there. See if that's going to even make any difference. Yeah, I polished it up a little bit. Okay. More tool out of the way. Okay, let's wipe that off. All right, so there's our thickness, 125/05, pretty much right on there. All right, now that we have our gyro mostly finished, there are some sharp edges on there, and we do still need to drill the hole in the middle there for the spindle to go through. What I'm going to do is now is put this back in there real quickly. We're going to touch this up with a Brillo pad, shine it up, take off those bright edges. Brighten it up and take off those sharp edges with a Scotch pad or a Scotch-Brite pad. So I'll go ahead and load that back in real quick. There's no precision on this one since we're not cutting anything. Move our tool way back out of the way. Okay, I'm gonna run it in the forward direction. I'm gonna run it up a few hundred RPM there. This is an abrasive material. It's sometimes used for like stripping paint and stuff. Works great for getting rust off of things. It's also just abrasive enough that usually will just take off any little burrs or sharp edges if we give it a good rub down. In fact, let's go ahead and we're at 300 RPM there. If we put this all the way down low, switch over to our high range, about 600 RPM. That's going to get us our polishing job here a lot quicker. So similar to filing, you know, I'm not working over the part this way. I'm staying to this side. If something catches, you know, I can just let go. You know, so I'm not actually sticking my fingers in there. I'm using the pad itself, so if something catches, hopefully it's just the pad. All right, that should take off any sharp edges and brighten things up a little bit, make it look a little nicer. So we'll go ahead and stop there. We could come back with some sandpaper, some fine grit sandpaper or something if we wanted to really polish this up. All right, that's good. All right, and there's our rotor. Reasonably clean inside there, get a little smoother. That's it. For the next process, we're going to go ahead and drill out and then remount the hole that's in the middle there. So I do want to put this back in where it was, so I look for my indication mark on there. Make sure our jaws are real clean. And this is one that we want to make sure that our part is in there really flat, because when we come back and drill that, if our part's off in there, it's going to get this wobble in it when we spin it. So I'm going to kind of tap and tighten as I go here. Okay, nice and flat up against our soft jaws there. We can get our tool bit out of the way completely. Because now we're going to come back in and use our tailstock here. So you can see, I'll load this thing here. I'm going to press back. I'm getting that to lock in there. And then it's in. So now I'm going to move these out of the way a little bit. Okay. And let's do a little housekeeping here for some of these extra shavings, chips.